Welcome to this lecture video where we will discuss the attenuation of seismic waves. So the word attenuation just means a decrease in the amplitude of a wave with distance. Okay, so the wave is getting smaller the farther away it goes. If you think about an earthquake and how energy is put into the ground in every direction, right? And so when you think about locations on the surface most impacted, assuming you have the same sort of geology everywhere that's going to be impacted by this event, you're going to have the most ground shaking at the epicenter. And then as you get farther away from the epicenter, there's going to be less and less ground shaking until at locations very far away, humans probably won't even be able to detect that shaking, although maybe some really high sensitive seismometers might. So why do waves lose energy as they travel through the ground? Well, this is primarily due to two factors. There's a couple other things, but the big two, the first one is called spherical spreading. So remember, energy is spreading out in 3 dimensions as it traverses through the ground and even through the air. So what starts out as a whole lot of energy here at the center is forced to spread out as it goes. So at some time t=1, the energy is spread out over this area, and at some time later, t2, it's spread out over a larger area, and even later it's spread out over this same, this great big area, but it's the same amount of energy as before. So the simple fact that the energy is forced to spread out over a larger area means it's going to have a smaller amplitude. Just like if you order a pizza, the more people you have to share it with, the smaller your slice, right? The more distance you travel, the more space the energy is taking up, so the less energy per unit of space. This is going to decrease the amplitude of our waves. The other thing that happens is that energy is actually absorbed by the ground. So anytime you have, so the example here, you can even think of as an analogy of light, right? You might have light coming in and some of it might be transmitted through a surface, some of it might be absorbed, and some of it might be reflected. Same thing with the seismic waves as they bounce around beneath the surface. The absorption energy, that's actually a conversion of energy from kinetic energy of motion into heat. You've all experienced this. If you've left a piece of metal out in the sun, it's going to be reflecting light waves. That's a reflected energy you might see as being very bright. It's going to absorb energy and it's going to heat up that metal. And depending on the metal, it might be able to transmit some light or perhaps not. Metal's not very good at transmitting. But hopefully you get the idea here. Some energy is absorbed by the substrate. It goes into heating that substrate a tiny bit. We generally don't have thermometers down there. We can't measure that except in the laboratory, but we do know that it happens, and it's one way that these waves lose some of their energy, aka they decrease in amplitude. So in this video, it's showing you a seismic event, and the darkness of the line is representative of the amplitude of those waves. And you can see at this close station here, the amplitude of the wave is very large, but as that wave travels away from the source and its energy is both spread out and absorbed by the ground, the amplitude of that energy along that line decreases, so that here at your next seismic station, it shows up with a much smaller amplitude. Over here, we're just sort of seeing the same thing. The graph has been sort of rotated, but if you examine a pulse, when it first enters the ground, it has a very large amplitude, and then the farther down it travels, it loses amplitude. So if you were to sort of take a snapshot of that wave at some later time, it would have a smaller amplitude, and at some later time, it would have an even smaller amplitude. And here you can see the large amplitude, and then as time goes on, that amplitude is getting smaller and smaller. So that's it. This concludes the video of attenuation of wave energy. This just refers to a decrease in the amplitude of the wave that corresponds to a decrease in the energy of the wave due to the fact that that energy is being spread out along a sphere and some of it is also being absorbed by the medium. That concludes, and thank you for paying attention.